See how well this works out. Okay, guys. So I'm not sure what's going on this this computer here, but what I will do is I'll share for you what I'm looking at, and so my you can just see this, I guess. So here, so I've got the text here that we'll go through today, and we do have time. We'll go ahead and go through that. But here in my virtual machine, it's been hung up like this for over half an hour, and I'm not really sure why it's doing this. I think it has something to do with, so what I was trying to do today was I was trying to set up networking, because what we're doing is, what we need to cover in this this lecture today is the whole SSH and how to connect to a computer across the network. And unfortunately, I tried to set up networking. I tried to set up two virtual machines side by side and get them to network to each other, and this is what ended up happening. So now I don't have any virtual machine that seems to be working today. So unfortunately, I won't be able to do examples unless this issue clears itself up somehow in the next hour. And so what we will do, though, is we will go over the text. You can at least see some examples there in the text as we talk. And then I'll try to figure out some way to get you some practical examples. Because what I would like to do, I like showing you guys examples. I believe strongly that in anything that we try to learn, whether it be system administration, programming, in my case, trying to learn Turkish, in some of your situation when you tried to learn English as a second language, to me, the best way to learn stuff is to practice it, is to, have conversations in English with your English-speaking friends. For me to have conversations in Turkish with my Turkish-speaking friends and colleagues. And then in the case of this particular class, is I really believe that you can sit here and read a textbook all day, but until you actually sit down and type out the commands and see how it affects the system, it's just going to be here, like just this abstract knowledge, but you won't really have the practical experience. So if we can't get around to it today, I will do what I can in the next day or so to figure out how to get you guys some practical examples that you can actually see working out on the screen. Okay, but for now, all we have access to is the text, so I'll go ahead and go with that. So let me share that screen so we can go through it. All right, so this was the first section of chapter 9. We already went through this one section last week, but I want to go ahead and review it. Okay, I want to make sure we kind of what's the word? Get your warm up your brain, right? Warm it up and get you ready for the rest of the stuff we're going to talk about today. So the whole idea of this whole SSH, or Open SSH for Linux, the Open SSH secure shell, is for us to be able to connect remotely to another computer on our network, or a computer that we have a connection to. So the idea is that if we want to be able to access things on a computer somewhere else without having to get up from our desk and walk over to the other computer to be able to get there, because in some cases it might not even be possible for us to do that. The other computer might be in another building, in another part of town. The other computer might be behind a locked door that we don't have physical access to, and so there's all kinds of reasons for why we might want to log in remotely, especially, you guys know, today, right? In today's world where we're having these lockdowns and we're having these curfews we have to deal with, there's a lot of people that are having to work remotely, right? And so we want to be able to connect to another computer somewhere else, but we want to make sure that we do that securely. So that's the whole idea of the whole secure shell, is we want to do that with trust that the people who are accessing these other computers actually have legitimate access to them. Okay. So, as we talked about, you could just use SSH with some other host name, some other place out there on the network. And what this would do is this would connect you to the same username that you're currently logged in as on another place's computer, on another host on the network. You would type in that password and you would be able to be connected to that other host using that same username. Okay. One thing to note, the password on the remote host may not be the same as the password on your computer. If we had a situation where all the passwords for a certain user were were the same across the network, then we wouldn't need this. But in this situation, the password on the remote computer might not be the same as the password on the host computer. A good system administrator, though, for your standard user accounts, for the typical user accounts, will make sure that all our passwords. That way you don't have to memorize a bunch of different passwords based on which host you're logging into. All right. You could also log in as a different user on a different host. So here, if you just type in the one name here, it says, okay, he wants to get onto a remote computer. Here, it's saying he wants to log in as a particular user on a remote computer. Okay, and it's the same as before. You still need to know the remote user's password. Okay. You can run a single command. We talked about how this was the same. This was similar to switch user, the SU command. This format is more like the sudo command, where we run a single command as a remote user at a remote host, and we run a particular command. Okay. So what happens is it asks us to tell the remote user's password. Once we do that, it runs the command, which is host name, and then returns us immediately back to where we're logged in as here. Okay. All right. Again, we talked about last week the W command being a way we could show users that are currently logged into our computer that we're on. So here we see the student and root, and we have a visitor here. We have a visitor that's logged in from another location. So this visitor, what this tells us, so if we look back at all these other ones, there's :0.0, what this all tells us is that these users are logged in, well, this user, because it's a student user, is me, right? Or it's logged in at this computer, and it's running stuff right now on this computer. So this is me, right? So when I run this command, I'm really just looking at what I'm doing, right? But here, this tells us there's somebody that's not logged in locally. There's somebody that's logged in from a distance. And this person's name is visitor, and this person's name is visitor, and this is where they're logged in from, and this is what they're doing. Now, right now, what this bash says is simply this user, they have a terminal window open, right? That's all they have right now. Now, they've had a terminal window open, it looks like, for a while. Let's see. Where does it say? All right, so they logged in at 9:22 today, and they've been doing stuff. Oh, not for a very long time. They've been doing stuff for like 3 hours. Okay. No, sorry, 3 minutes, not 3 hours. 3 minutes. So they haven't been logged in for very long. They haven't been doing a lot of stuff. We might be more concerned if we saw some more activity, especially anything that looked suspicious. But this just tells us that they have a terminal window open. They've had it open for about 3 minutes. All right. Okay. Now, when we go to connect, when we connect through SSH to a remote computer, we get a host ID. The first time, we get their public key. Now, those of you who have taken or are taking a cybersecurity class, you'll know all about this whole public key, private key encryption. We'll talk about it a little bit in this class. It is part of the next section of this chapter. But it's not, we're not going to go into too much in depth here in this class. This is more for your security class. Okay? But the whole idea is when we log in through SSH to another host, we get its public key. Its public key is something that is, you're going to see in the next section, it's used to verify network traffic. It's used to verify that the person who's being sent to and the person who's being sent from, it really are who they say they are, that it's not some spoofed address or anything like that. It's not, there's not suspicious activity going on. So when I log in through SSH, I get that other server's, that other host public key, and I put it into my known hosts file. It's it's encrypted. It's not a plain text key. But what happens is that then when I log in anytime from then on to that known host, to that same remote host, it gets that public key again every time. Every time we log in through SSH, the public key is sent. And that's not a problem. Okay, public key, it's named public because the public can see it. Anyone can see it. This is not a problem. If you give your public key out to everyone, that's fine. Okay. Now, when the public key is sent again, if it matches the public key I have already, I say, okay, this is still the same person. That is who I think it is. So it lets me log in. If the public key is different from before, then when I notice that, when my computer notices that, it says, wait a second, this may not be the right person. This may not be the right host. Something is different. Something's weird. And so what will happen is that the connection will be dropped. The connection will be stopped because it says, okay, the known host, public key, and the public key that is now being given to me are not the same. That's suspicious. I'm not going to connect to this computer till I know this is who it says it is. Okay. Now it could be just that a server's public key was changed, maybe it was lost or replaced for some other legitimate reason. And in that case, we will update the SSH hosts. Okay. And that we show how to do that. Okay. But if we have a public key in here, and we get the public key and they don't match, until they match, we're not going to let remote login go on from our end. Our computer won't allow it. Okay. All right. So that covers that first section. That's what we covered last week. Over the next 20 minutes or so, we're going to finish off chapter 9, and then we'll do chapter 10 in the second hour. And unless my virtual machine comes back, which it still has not done, then we will just we'll call it a day after 2 hours today. Okay. All right. So this is some practice of how to do that. Okay. Oh, by the way, this example, guided example, it says that if we remove the known hosts file, right, then when we go to log in again, it will allow it to happen because there won't be any known hosts at that point. So that's one way that we can force that login. The problem with doing it this way is it gets rid of all known hosts across the network. So we kind of lose our security with all the other servers we might be trying to log into. Okay. All right. Look through this example. Again, these examples, this guided example for both this chapter and chapter 10, logs, have both been put into that class materials folder. Okay. All right. So let's talk about this whole key, public-private key encryption. Okay. So we can copy. We can generate. We can generate our own key. We generate our private key that can be used to verify that stuff being sent to us really is supposed to be sent to us. Okay. Let me let me pull up the whiteboard. That's what I'm going to do, because I want to show this. I want to show this in such a way that it's maybe a little bit clearer. Okay. All right. So what I want to show you guys is how this public key, private key kind of works. Okay. So imagine, if you will, we have, let me do it in black. Okay. So let's imagine we have this piece of plain text, like this information that we want to send, across the network to another computer somewhere else, and we want them to get the same thing, right? Okay. Now, there's a couple of different ways that we can do that. One, we could just send it as plain text, right? And the problem with that is, what happens if somebody, what I am going to make the network not red, but green for go. Okay. The reason why is I want red to represent this bad actor, this other guy out there, this other computer who wants to try to get our data, who wants to try to get our information, right? Okay. All right. If we send it as plain text, nothing stops them from getting it, right? Nothing stops this computer from, if they can, get this file as it's being transferred. If they get that information, if it's plain text, they can read it, no problem, right? So that's a bad thing, right? We don't want that. Okay. So what we can do is we can encrypt it, right? All right. And let's use blue for this, right? So what we can do is, if we take that plain text and we put it through an algorithm to encrypt it, okay, so now what we get is we get an encrypted version of this. Then what they're going to see is something else. They're going to see, let's say, instead of horizontal squiggle lines, we'll do it like vertical squiggle lines so that it looks different. Okay. All right. Now, what we can do, a very simple algorithm might be, shift all the bits by one position or something, right? So that it's gobbledygook. It doesn't make any sense. All right. And then what would happen is the person on the other end, okay, they would apply a decryption algorithm, right, that would then undo the encryption. Okay. Now, there is one format of this where it's sorry, I don't teach the cybersecurity class, so I'm blanking on the names. But there's one where if you apply the same algorithm twice, so if you apply one algorithm to encrypt, you apply that same algorithm again to decrypt, right? Then what happens is it decrypts it. Okay, so there's one format of that. This is not the one that Linux that SSH uses. This is a different thing. But I do want you to understand that this is the most simple version of this. This way, you have a key. Let me draw a fun little key in here. I'm terrible at drawing, by the way. Okay, so let's say it's the same key. Okay, twice. right? So the same key is used to encrypt as it is to use to decrypt. Okay? Now, this is simple. You only need one key. You only need one algorithm, and you're done. Right? It's simple, but what happens if this bad actor over here, what happens if they get access to that key somehow? Right? If they get access to the key, we've lost all our security. They can just decrypt whatever they get. Okay? So it's simple. We have one key. I have a key I share, but if this person gets that key, then they can get our information. All right. So it's a level of security. If they don't ever get the key, then we're fine. We're great. Right? But if they get the key, then that's a problem. Oh, the reason why is, again, this is very simple, very fast encryption, decryption. But how do we get the key from this computer over to this computer? If we send it across the network, that's how the bad actor could get that key. Okay. Remember, this is kind of like what is it? Like a literal key, like to your door, right? That if you give a copy of your key to the door to your house to a friend of yours, they can come in your house. But if they make a copy of it, or if they lose that key and it gets, to some thief, if they get a hold of that key, they also get to go in your house, right? Okay, so this is adds a level of security, but it's not what SSH uses, because it's not ideal. Because if a key gets stolen, if a key gets copied, how do we get it from computer A to computer B? Actually, let me go ahead and call them that, A and B, and we'll call this bad guy. Okay. All right. So, how do we get it from computer A to computer B? Well, if we send it across the network, bad guy could get the key. So we have to get it from computer A to computer B some other way. Well, what happens if computer A and B are cities apart? How do we get it? We have to transport it by USB drive or something. That can get really time consuming and a problem, right? Okay, so all of this was said to say this is what SSH doesn't do. So let's talk about what SSH does do. Right? It uses what's called the public key, private key encryption. So I'm going to use yet another color. Do I have another color? Doesn't really look like I do. What is this? Oh. Okay. Do that. So we have a public key, private key pair. Okay, so I'll draw another color key over here. It's kind of weird looking. Okay. All right, so these are two different keys. Now, the way this works is that anything encrypted with a public key gets decrypted by the other part of the key, what we'll call the private key. Okay, but it works both ways. So if we think of it like this, let's say we had a piece of text. Let's call it system. Let's just say the word system. We're in the system administration course. So system. Okay. Now let's say that my private key, let's say my private key, the way it encrypts stuff is it just adds 1 to every letter in the plain text that it gets. So S becomes T, Y becomes Z or Z, S becomes T, T becomes U, E becomes F, N becomes N. Okay, so T, Z, T, U, F, N. Okay, this doesn't mean anything to us, right? Right? You couldn't read that, right? But if we applied the same key, the same encryption key to this again, we would just get T. We would get U, whatever might come after Z. in ASCII, I don't remember what that is, U, so forth, right? So what we have is the encryption pushes everything up a letter. The decryption pushes everything down a letter. So S, Y, S, T, E, M. All right, so we got back what we put in. Okay. This is a very simple example. This is obviously not how algorithms work, right? But this is just a very simple example of how we might encrypt and decrypt. So this would be the public key. This would be one of the public or private keys. We'll call this the private key. Private key, and this is what the public key does. Okay, and the reason why I'm going through all this is because I want you to understand something. It works both ways. If I were to encrypt using the private key, and the private key adds 1 to every letter, and decrypt with the public key, I get the same thing back. And it works the same thing in reverse too. If I were to encrypt with the public key, so remember the public key takes 1 down off of every letter. So S becomes R, Y becomes X, S becomes R, T becomes S, E becomes D, M becomes O, right? So here we've encrypted using the public key, and if we decrypt using the private key, add 1 to every letter, guess what? We get the same thing back again. Okay. All right. And so this is used for security because what can happen now is A sends its public key to B. Doesn't send its private key, it sends its public key to B. Okay. Now, when A encrypts using its private key, B decrypts using its public key, and B can know that what came from A really did come from A. So we have some security there. Right. And on the other side of that is when B sends things to A using its public key, using A's public key, then A can decrypt using its private key and know that it really was supposed to be sent to A. Okay. The reason why this becomes important is how does this defeat the bad guy? You know, my oldest son is really into like Marvel movies and stuff, and he's all about defeating the bad guy, right? Okay, so how does this defeat the bad guy? If I encrypt something, if I'm sending from A, and I say, okay, I'm going to encrypt what I'm doing using my private key and B's public key, then when B decrypts using A's public key and B's private key, what we now know is that this message can only be read by someone who knows A's public key and B's private key, so only B can have access to that. And the same thing goes the other way as well. Because the thing is, yeah, bad guy over here, he might have A's public key. So he can know that anything that's not encrypted using someone else's public key, if he intercepts a message, he could decrypt to the level that he knows it comes from A, right? But because he doesn't know B's private key, he can't get the original message. I hope that's clear to you guys why this is important. Because using that combination of that private public key, what that lets us do is know that messages sent from A can be confirmed to be sent from A. Messages that are sent to B, we can confirm B's private key can confirm that those messages really were supposed to be sent only to B. So then if we have a message that does both, we know what we have is a message that came from A, and we know that it came from A, a message that went to B, and we know it's intended for B, and no one else is allowed to decrypt that message because they are not the intended recipient. Also, if a bad guy tries to send something to B pretending to be A, he doesn't have A's private key, so he cannot encrypt in such a way that it could be read. What will happen is if bad guy over here sends a message to B saying, hey, I'm A, and this is my message for you, when B decrypts according to its private key, he realizes, yes, this was really intended to be sent to me. But when he tries to decrypt using A's public key, he'll get a bunch of gibberish. He'll get a bunch of nonsense. There's a Turkish word for that, but I can't remember what it is. He'll get a bunch of nonsense, and he'll know this didn't really come from A. Okay, so we've defeated the bad guy here. Now, if somehow, this is where the known host thing comes in. If somehow bad guy over here gets access to A's private key, he can start causing problems. Which if we find out that some other bad actor out there, some other bad person, some other non-authorized computer out there has access to A's private key, what we'll do is we will change A's private key, and then that's when that whole known host thing comes into play. That when B tries to connect A, hey, your public key isn't the same anymore. That what happened, and then we can update B with the new correct public key. All right. So I did say I wasn't going to talk too much about that, and I talked more than I anticipated because I do think it's important. So let me share over here. Back to this guy. All right. So we can generate our own public-private key pair to send across the network, to be able to copy into others, so that they can log into us directly and we can log into them directly. Remember, what we're trying to do is we're trying to set up a situation, this whole SSH service, we're trying to set it up so that the user, a user, is that in this section or the previous one? It's this section. Let's see. Let me go back before. Okay. So what happens is that, okay, we generate that key pair, the public-private key pair. We save it. Okay. We enter a passphrase to be able to encrypt. This is for the hashing algorithm. Okay. And then we can copy it into some other location on the network, on the remote system. Now, what happens is that because we're copying my public key into somewhere else, some other remote system, what I'm giving access to be able to do is to be able to log in using SSH without having to enter my password every time. So you guys remember the examples that we did in section 1 over here. Every time you went to run a command, every time you went to log into that remote computer using SSH, you had to type in your password, right? We don't want to have to do that every time. What we'd like is, just like with the sudo command, is we would like to be able to run a single command across the network on a remote computer without having to type in my password. Okay, and that's what this is going to give us the ability to do, because when we send our public key over to the other computer, they now know that things coming from us really are coming from us. Commands coming from my computer really are coming from my computer. All right. So that's what this all is about, is that we can copy it over there. And so see, now we can SSH server X, we can run the hostname command, and we don't need to enter our password anymore because it knows that we are who we say we are. Okay. So again, look through this example. Do you want to customize? So give me a few more minutes here to go through this last section here, and then we'll take our break and move to chapter 10 for the second hour. Okay. One of the things that we may want to do is we might want to prohibit the root user from logging in using SSH. Okay, so what we might want to do is remember, we want to limit the amount that typical users can log in using root access. You know, the root has unrestricted privileges, and we don't want them to necessarily be able to get access. Okay, now. The reason why is because, remember, if we configure this SSH service, key-based authentication, we could get across over there without using a password, right? And if an attacker can guess the password of root, sorry, if the attacker can guess the password, know that every Linux system has a root user. So the thing is so let me just take a look at who's on the call right now. Let me call one of you guys out. So let's say, Burak, you were the first one on the call, actually, so let me talk about you. So let's say your username was bkeskin on a Linux machine. Somebody could try to guess that, and then they could try to guess your password, but that may not be how we do usernames. We may not do Burak bkeskin. We might do Burak would be your username, right? And so somebody would have to guess your username and your password to be able to get access. But if they know every Linux machine has a root user, now all of a sudden all I have to do is guess what the password might be. So yes, it's still difficult. It's not easy, right? There's lots of password cracking algorithms that take a long time to try to figure out passwords, right? But root, but if we take one part of the guessing out, the name, then that is the amount of things they have to try to figure out substantially, right? So the problem is known username that has unrestricted privileges. So we want to limit how much people can do that, right? So we can go into this SSH config file. We can change permit root login to no. And now, remember, we restart the SSH because we want to reload the new, we want to have the new configuration. This is a configuration thing, right? So we want to also, we could also say permit, only allow key-based SSH as root. Okay. So you could permit root login without password. Okay. So we could also then prohibit. So this is how we do not allow root to log in from using SSH. So the root user won't be able to log into the system using SSH once the SSH service has been restarted. So they won't be able to log in as root across the network. We also might want to prohibit any password authentication. So once this is done, no one will be able to log into a remote computer using SSH with a password. They will have to use key-based authentication, which was not the password, right? So that was what we covered in this previous section. That's key-based authentication. Okay. So we can do this. We can say password authentication, change it from yes to no. Now what will happen is the only users that will be able to log in through SSH to our computer will be those who have keys, have generated the key pair, and have copied the keys across the network. Okay, So it's only the ones that are able to access through key-based, non-password authentication that will be able to get access to our computer. All right. All right, so then this is an example. So again, we copy the keys across the network. We SSH, all right. We do not allow root login. Now, one thing I do want to make a note about, all right, is so they use the same correct password 3 times, by the way, in this example. Okay. One thing I want to make a note is look at the error message that we get. It doesn't say, oh, SSH root access is not permitted. It doesn't give that information. Why do you think that is? Why do you think it doesn't say permission denied, root login not allowed on this computer or something like that? Why does it just say permission denied, please try again? What? Because root access isn't allowed, so why would it tell me to please try again? Why do you think that is? Let's have a brief discussion about this and then we'll take a break. This is fairly, in my opinion, is probably a very important part of how this is done. Okay, let's do this. Because maybe you guys don't understand the question. I'm gonna reword the question. We'll take the break. During the break, type in your thoughts. Let's have a little discussion, and we'll bring it back up at the very beginning of the next hour. So, the question is, we're not allowing root login. So no one can SSH into our server X. No one can SSH as root and get access. We've said no, you cannot get into this and get root access. Even if you know the password, you can't do it. Okay. So when they try to SSH into in as root, they get a prompt for the password, and then they get this message as permission denied, please try again. Why do you think it does not say root access denied, root access not permitted? Why does it say please try again? Because no matter what, if I put in the wrong password, it's going to say permission denied, please try again. If I put in the correct password, it's going to say permission denied, please try again. Why, if I put in the correct password, does it not tell me root access not allowed on this server? Okay. Think about that. Type in some answers. I want you guys to think about it and tell me what you think is the reason that the message is not more informative. Why don't we give more information? Why does it just look like they put in the wrong password? Okay. All right. So we'll take our break now. Think about that. And we will come back in 10-ish minutes. Okay. So about 10:40, 10:43, something like that. Okay. All right. Take a break. I'll see you guys in 10 minutes.